General properties of gases. Gases assume the volume and shape of their container, most compressible of the state of matter, mix evenly and completely when confined to the same container, lower densities than liquid and solid.
As you can see, these units of pressure.
What is gas pressure? Gas pressure is caused by gas molecules bombarding a container wall.
In gas law, we have Boyle's law, Avogadro law, and Charles law. In variable, we have P for pressure, T for temperature, V for volumes, and N for number of moles. Boyle's law. The pressure of a fixed amount of gas at a constant temperature is inversely proportional to the volume of the gas. On the right side, we can see the Boyle's law illustration, and the equation is P1 V1 equal to P2 V2. On the left side, we can see the volume and pressure plot, and the right side, we can see the application of Boyle's law. For example, breathing, inflating tires, soda bottle, working of a syringe, spray paints, and spacesuits. Charles law. The volume of a fixed amount of gas maintained at constant pressure is directly proportional to the absolute temperature of the gas. For the first equation, we have V1 over T1 equal to V2 over T2. And the second equation, we have P1 over T1 equal to P2 over T2. On the left side, we can see the Charles law illustration, and on the right side, we can see volume and temperature plot. Next, application of Charles law. First, we have hot air balloon. Second, helium balloon on cool day. And third, pop-up turkey timer. Avogadro's law. At constant pressure and temperature, the volume of a gas is directly proportional to the number of moles of the gas present. This is the example of Avogadro's law. And this is the application of Avogadro's law.
Ideal equation for gas state is PV equal nRT. As we know, P was pressure, V was volume, and R number of moles, R was gas constants, and T was temperature. To fix N and T, using Boyle's law, V equals to constants over P. To fix N and P, using Charles' law, V equals to constants multiplied with T. To fix P and T, using Avogadro's law, V equals to constant multiplied with N. For value of R, we are using value of universal gas constants, and it depends on the unit that we are using. Standard temperature and pressure STP. For standard temperature was 0.0 degrees Celsius or 273.15 K. For standard pressure, 1 atm, 760 torr, 760 mmGh, 101,325 pascals, and last 101.325 kPa. At STP, 1 mole of any ideal gas has a volume of 22.42 liters. Gas stoichiometry. When the reactants and/or products are gases, we can also use the relationships between amounts, moles, N, and volume V to solve the problems. Stoichiometry was reactants to products. For example, what is the volume of CO2 produced at 27 OC and 1 at 0.00 atm when 5.60 gram of glucose are used up in the reaction of C6H12O6, 6O2, 6CO2, 6H2O. To find the answers, we can find the gram of C6H12O6. Then we find the mole of C6H12O6. Next, we find mole of CO2, and last, we find volume of CO2.
Dalton's law. The total pressure of a mixture of gases is just the sum of the pressures that each gas would exert if it were present alone. P total equal to P1 plus P2 plus P3 plus P4 plus continue to the next number. Mole fraction. The mole fraction X is ratio of the number of moles of one component to the number of moles of component present. In general, the mole fraction of component A in a mixture is given by mole fraction Na over N total, mole fraction component Na over Na plus Nb. For Na is number of moles of substance A, and Nb is number of moles of substance B.
Graham's law, effusion, diffusion and gaseous motion. Effusion, the process by which a gas escapes from its container through a tiny hole into an evacuated space. Diffusion, the process of gas movement of one gas through another. Rate of effusion. Graham's law states that the rate of effusion of a gas is inversely proportional to the square root of its molar mass. Deviation from ideal gas behavior. Kinetic molecular theory. First, gas consists of tiny particles of negligible volume. Second, intermolecular force of attraction do not exist between gas particles. Third, gases are in continuous random motion. Fourth, the gaseous particles are perfectly elastic. Last, the average kinetic energy of gas directly proportional to the absolute temperature. Deviation from ideal gas behavior. Deviation from the ideal gas behavior happen at two conditions, high pressure and low temperature. At this condition, the gas behave as real gas rather than ideal gas. Under this condition, the two basic assumptions, gas molecules have negligible volume, intermolecular interactive are negligible. Ideal gases versus real gases. Ideal gases volumeless, do not interact with each other, molecules would travel in straight line. Real gas, finite volume, particles do take up space, volume of the gas is actually less than the volume of the container. Particles do attract each other, path work off due to the attraction between molecules. Molecular speed. Although the molecules in a simple of gas have an average kinetic energy, the individual molecules move at various speed. They exhibit a dispersion of speed at the same temperature.